Hello everyone, this is Godfrey Deputra, working as Associate Professor in Mechanical Engineering Department of Maharaj Institute of Technology, Mysore. In continuation with the earlier video, this is the second video which I am giving to you, wherein I am going to teach you now the procedure that is to be used in order to solve an LPP by using Simplex method. There are certain terminologies which needs to be understood before we get into how to solve a problem. So, say for example, if there is a question which is given, let us look into the question now. Maximize z equals 2x1 plus 10x2 plus x3, subject to constraint 5x1 plus 2x2 plus x3 is less than equal to 15, 2x1 plus x2 plus 7x3 is less than equal to 20, x1 plus 3x2 plus 2x3 is less than equal to 25. Non-negative constraints x1 comma x2 comma x3, all of them greater than equal to 0. Before we get into the procedure, let us first check whether the conditions that I had explained to you in the first video, whether it is holding good here in this particular case. It is a maximization type, so therefore there is no problem with that. All of the inequalities are less than equal to sign, and all of the RHS are also positive, and x1 and x2 and x3, all of them are bearing a value which is greater than 0. So therefore all of the conditions are satisfied, so that we can follow the procedure. Before we get into the solution, we need to bring it into standard format. That is, we need to convert all of these inequalities into equalities by using slack or surplus variable. So therefore I'm going to write the constraints once again by converting the inequalities into equalities. 5x1 plus 2x2 plus x3 must be equal to 15. So here in this particular case, the variable that I'm supposed to use in order to bring the LHS and make it equal to RHS is a slack variable. The reason is the inequality that is given here is less than equal to, so by virtue of the equation that is given, the LHS is already very much less than 15, so I am supposed to add something to the LHS, so in order to make it equal to 15, so therefore I'm going to add S1 here. Similarly, it is the case with the second equation, is equal to 20. So similar to the third equation, x1 plus 3 x2 plus 2x3 plus s3 is equal to 25. So observe that now the number of variables in the equation has become more. x1 comma x2 comma x3 comma the slack variables that is introduced here in these three constraints have now become basic variables. All of them are greater than equal to 0. So therefore these slack variables needs to be incorporated in the objective function. So therefore the objective function becomes 2x1 plus 10x2 plus x3. Note that here I'm going to add these slack variables here, but with a coefficient called as 0. This is as per the procedure. Okay, so we have reformulated the question. First we checked the conditions. It was maximization type, so it was the first condition was satisfied. All of the inequalities have been converted to equalities. All of the RHS are found to be non-negative values, and all of the variables are themselves greater than equal to 0. In order to now solve this particular LPP, we are supposed to make note of a few important relations here. First most important definition that we are supposed to understand is basic variable. So here the basic variable, as I'm showcasing here, are these variables x1, x2, x3, s1, s2, s3. These are all the basic variable. Now the second most important definition here is coefficient of these variables in the objective function. So this we represent as a CBO, C suffix BO, which says coefficient of the basic variable in the objective function. So here the coefficient of basic variable x1 is 2, x2 is 10, x3 is 1, s1, s2, s3 are 0 in the objective function. Now let us get into the procedure before we try to understand all of these other 8 terminologies. we construct a table comprising of all of these variables like this. So here we make note of the coefficient of these basic variables in the objective function. So here, as you can see from the objective function here, the coefficient of x1 in the objective function is 2. So therefore I'm going to write it as 2 here, 10 here. 1 is the coefficient of x3 is 1 in the objective function, and the s1, s2, s3 are 0. Here we do not write any values. So this is the primary table that we use for the first iteration. Now the set of values that needs to be assessed for its existence in the set of equations here are the slack variables themselves. So therefore I'm going to write the slack variables here, and I'm going to write one more row, call it as z equation, and this z equation is supposed to be filled by using this function, this equation that is given, that is summation of CBO into XI minus CO. How exactly it is supposed to be done, I'm going to simply teach you right now. Okay, so the first set of values that I'm supposed to write here in order to fill this table are derived from the question itself. So here for the first column, which are corresponding to slack variable number s1, I'm going to use this first equation, that is 5x1 plus 2x2 plus x3 plus s1, which is given. So therefore we are supposed to write the coefficient of these s1, s2, s3 here are 0. So therefore I'm going to write these values as 0 here. So corresponding to these values which have written here, called as 0, 0, 0, 0, represents the coefficient of these slack variables in the objective function, which we are already written here. Okay, so in order to fill the cells that is corresponding to slack variable of s1, I'm going to use the equation that is in the first equation. So I'm going to fill these values as 5, which is taken from this equation, 2, 1, and the coefficient of s1 in that particular constraint is 1. There is no s2, there is no s3, and RHS is 15. Similarly, please bear with the inconvenience of this video being moved around, difficult to manage, but I hope all of you can bear with this. The second row that I'm supposed to fill is by using the second equation. So therefore here the coefficient of x1 in the second constraint, which consists of the slack variable s2, is 2. Then for x2 it is 1, and then x3 it is 7. Then there is no s1 over there, so therefore it becomes 0. There is s2, so therefore its coefficient is 1. There is no s3, so that becomes 0, and then RHS is 20. Similarly, the third row which consists of slack variable s3, we are going to use the third equation which consists of s3 here, so therefore it becomes 1, 3, 2, 0, 0, 1 and 25 is the RHS. So this is the first table that needs to be filled like this. Okay, moving on. There is an observation that you need to make here. Whenever, regardless of how many iterations that we do, whatever variables that are available here in the form of basic variable, corresponding matrix will always be a unit matrix. Okay, so as you can observe here, S1, S2, S3, S1, S2, S3 here, so therefore it becomes a unit matrix. Now the calculation starts. The first most important set of calculations that we are supposed to make, let me keep the question apart.